Hi, everyone. Welcome to the 2020 edition of the Dev Summit. It's kind of an interesting one. You're watching us present topics talking about the advanced capabilities of the utility network. Here as our speakers, we have Dave.
Hello.
Dave is the product owner of the utility network and all that. You've been here at Esri, what, 10, 12 years?
10 years, going on 11.
And
Remy Myers, I'm the product manager for the utility network.
Okay, and I'm Eric Cole. I'm the dev lead on the utility network. So we're going to take everyone through some interesting things, what we consider to be the more advanced capabilities of the utility network. It still doesn't go into complete and utter detail, but this will give you a very good roadmap for where you can go online to learn even more. And hopefully you will be able to use it in conjunction with all of our online doc to really answer a lot of your questions that you may have. So anyway, what are we going to talk about? We're going to talk about the architecture of the system. Then we're going to talk about some of the more interesting or trickier aspects, things that people have a lot of questions on, such as versioning, the branch versioning model, what are network attributes, talk a little bit about the tracing framework and attribute propagation, as well as subnetwork management and network diagrams. If we have time, we'll have to see about that one. Along the way, Dave's going to be giving us some pretty compelling demos, try to show as much functionality as possible, demonstrating these advanced capabilities. And Remy will conclude by giving everyone a little bit of the road ahead, what to be expecting with the next release that'll be coming out around the UC this year, and then maybe beyond that, what sort of things we see on our horizon. So, the architecture. This is actually one of the more interesting aspects for us developers, and that was back when we started this project, Sud, our director of development, that you saw, of course, in the plenary, many of you know in person, he challenged our team to essentially create the first next generation dataset type. By that meaning the data set is completely services based. We want to move to a complete service-based architecture, and in so doing, we were instructed not to be supporting traditional client-server interaction with this new data set, the utility network, once it is published. Also, it's considered to be a very significant extension to the existing web geodatabase model. Now, the nice thing about the utility network was, well, we went through a lot of growing pains, a lot of teething. There was a lot of hard engineering to sort out, given that large challenge from SUD. But it really has become now a pattern for all of our service-based dataset development. And you've seen recently the Parcel Fabric was released, and with the 2.6 release that you'll see at the user conference, we'll have another network model, the Trace network. However, that one will not yet be services-based. That will come in a subsequent release, but it will get there. Now, so if you go and look at one of these nice sort of markety kind of slides, at the center of everything, we have ArcGIS Enterprise, and that has, of course, the utility network. It supports our transaction model. It supports the editing tools, provides the attribute rule framework and all the rest, and it serves as a gateway to server. Now, the other things that we have, who are the clients of Enterprise? Well, we have the desktop things, ArcGIS Pro being the premier desktop. That's where you do your design and maintenance, map authoring, analysis, all the rest that you would expect. It also, because it is a service-based architecture, we support, Enterprise will of course support devices. You can have your mobile devices, you can have your phones, you can have your tablets, and you'll be able to use the utility network in those environments. Now, we've been working very hard in that arena, and some functionality has already been released there to allow you to do tracing on mobile devices if you are in a connected environment. In the future, we're going to be making it more powerful and the ability to do things disconnected as well. Finally, of course, being the last piece of a service-based architecture, web apps. Okay, people can author web apps using JavaScript to hit the REST APIs that are exposed through Enterprise. And so we've already seen people writing and developing compelling applications through web browsers that allow you to do things like simple editing. I've seen applications where people are doing tracing or even subnetwork management, creating dashboards, all the rest. So as you can see, supporting a service-based architecture through Enterprise is sort of the key to our future growth and the model that we're really trying to push forward with. Now, in a little bit more detail, How would you conceptualize this? This is breaking it down a little bit. So you see the big box being ArcGIS Enterprise on the back end. Everything is communicating from the front end, ArcGIS Pro or the managed SDK, which talks to the geodatabase, and that'll then go through JSON, the yellow arrows, to communicate to REST APIs that are exposed on various different services that are exposed as part of the utility network constellation. We see, of course, the feature service that's been around for quite a while, but then we have some new ones, such as the utility network service that allows you to validate your network topology, do trace operations, update your subnetworks, whatnot. We have the network diagram service. That's sort of where you build, manage, create your network diagrams, your schematic representations, or your logical representations of the data contained inside your utility network. We also have the version management service. That's another new one that allows you to work with branch versioning. This is both for things like creating versions, managing your versions, doing reconciles, doing posting, deleting versions. All things versioning goes through this version management service. And then we also have a validation service. That's the way that you can, on the back end, actually do things with your attribute validation rules, where you can actually evaluate attribute validation rules or batch-oriented attribute calculation rules. Okay? So everything that you see Pro doing is going through services. It's going through JSON communication to the REST APIs. Okay? Very interesting, truly a service-based architecture. Now, if you looked at it from a traditional client-server standpoint, here it is. You see the geodatabase just talking to an enterprise geodatabase through the SDE workspace. Now, with services, we actually go through a different workspace implementation, essentially the feature service client, and then that is the gateway, forms the gateway that allows us to talk to enterprise. And again, on the back end, you'll see enterprise geodatabases talking in traditional client-server mode on the back end. Now, what if you're running web apps with a JavaScript SDK? All you're doing is you're swapping out the Pro client app and putting in a JavaScript SDK that's, again, going through the same JSON, hitting the same services against ArcGIS Enterprise. So the back end is completely the same. Of course it is. Then, if you're in the runtime or mobile environments, things change a little bit differently. You have different SDKs that are exposed, such as Qt or iOS or Java, macOS, Android, whatnot. And then they're going, and again, when you're connected, hitting the services through JSON going against the REST APIs. And the nice thing with mobile, the mobile applications is you do have mobile geodatabases that are local that you can utilize as well. So, when we look at the utility network, what are some of the key technologies that are being introduced? First, the service architecture. We just talked about that. We have an information model that's actually completely designed and completely tuned towards supporting these next generation requirements of utility and telco customers. We have the ability to represent associations, linking things together, saying that this is connected to that or this is contained within that. We have a terminal model that allows you to model more sophisticated devices such as transformers that may have high side and low side bushings and whatnot that you can connect to. Or maybe you have check valves and water networks where water can go in one side and exit the other. So the terminal model is intended to support that. We have branch versioning. This is our new versioning implementation that we consider to be more scalable, more performant, and actually supports temporal-based interaction with the underlying network model. Network topology, that's another big subsystem. That's essentially our network index and our build algorithms, how we effectively index the data such that you can traverse through it and do analytic processing of it very rapidly. The trace framework is a collection of tools enveloped inside actually a framework that you can configure and do all kinds of configurable tracing operations against the network topology to answer your analytic questions of the data contained within your utility network. We have network diagrams. We talked about that a little bit earlier. Those are essentially schematics. It's built into the utility network. We realize that people sometimes want to look at their data in geographic space, but then sometimes they want to look at it in logical space. They want to look at a schematicized representation of their data. Engineers tend to like that sort of stuff. So network diagrams is wired into the utility network as a core capability. We have subnetwork management. That's the ability to manage the subnetworks, circuits, pressure zones, whatnot that occur within your models. Attribute rules. This is essentially the way to configure the system to enforce additional constraints using arcade expressions, essentially a scripting language that's very much like JavaScript that runs cross-platform. We have contingent attribute values to help define. This is a general capability of the geodatabase now, but it helps you have very streamlined user interaction when you're populating attribute values. The whole thing is really a framework. That's one of the big things here. We're not delivering a true utility solution. What we're delivering is a framework that allows you or business partners and others to extend and do amazing things with. So think of it as really being a core framework that can then be utilized and to develop applications and configurations on top of. Another important part is the Pro Managed SDK. We've had that in Pro for some time, but it exposes all the utility network and branch versioning abstraction. So you can do your C# programming of tools and widgets and whatnot inside Pro. We have mobile SDKs. We've talked earlier how the utility network right now is being enhanced and grown inside the mobile space, and it's available through the various different mobile SDKs that you can see out there, such as Java, Android, iOS, whatnot. The JavaScript SDK to allow you to do web-based development, well, there's already a JavaScript SDK, but you can do things, you can go, of course, go and hit our REST APIs, but we'll be trying to enhance it even further to provide you with utility network-centric abstractions that'll make it even easier to hit the services through JavaScript in your web apps. Being able to support single-user geodatabases, things like file geodatabases. That's very nice. Sometimes you're a small shop and you just have one editor, or maybe two people sharing the utility network if you're a very small shop. Well, you can run it on file geodatabases as well. Finally, non-spatial features. I think we'll have Remy talk a little bit more about that towards the end of this discussion. Versioning. What is versioning? Well, of course, we've had it since 8.0. It's a multi-user long transaction concurrent editing model. It basically allows multiple editors to edit in isolation all at the same time without having to copy the data all over the place. The versioning subsystem will manage and record the changes that are being made. And essentially, everyone has a virtual copy of the database. They think they have their own copy, but it's actually a shared instance that we go and manage. Now, branch versioning, that's a new versioning model that we developed as part of the utility network development that was created specifically to work in a service-based environment. In fact, it's only available through services. You have to use the version management service to have access to the management of it, or a client that is hitting the version management service. And the version management server only supports branch versioning. Let's see, what else? It can be used in ArcGIS Pro, and you're going to be editing against feature services when you use branch versioning. Right now, the utility network and Parcel Fabric are the only data sets available for editing there through branch versioning. This is, of course, being extended all the time. We're working to add more and more in there. Interesting thing about branch versioning, you can only have, it's much like traditional versioning, only one editor per branch version, or you can have multiple readers if you need to have multiple people. Now, when you're publishing data sets that are branch versioning enabled, you have to do it in releases after 10.5 of ArcGIS server. So 10.5, 1, 10.6, you can do that. If it's enabled under capabilities, all data sets must be the same registration type. The data must belong to a branch workspace, and you have to publish your data from the default version, okay? And the connected user that's publishing it must be the owner of the data. Also, definition queries cannot be present, and all fields must be visible when you're publishing. Network attributes. What are they? They're actually, when you go back and look at the geometric network model, it's much like weights, but actually a more sophisticated variation on weights, where we can take key attributes that are found in feature space and cache them inside the network index, such that trace tools, your analytic operations can make use of them in answering questions and determining what constitutes valid traversability inside the system in a more performant manner. Much like the network data set, which is our transportation network model, network attributes are a little bit more flexible than the old weight model. And yes, of course, it allows you to control the traversability. There are two different types. We have cost attributes, and we also have descriptors. Descriptors are more Boolean type things or base characteristics, such as is a switch open or closed, whereas a cost attribute may be something like a voltage level or a pressure level or something of that nature. And again, they are cached there for rapid consumption during the tracing operations. No big surprise. Tracing. That's basically how you go about analyzing your network. We have a whole collection of tracing tools out there that can then be configured to allow you to create very customized or very specific analytic operations against your utility network data. Allows you to do things like do inspections of the network after a severe storm, or determine the number of customers with access to the resource, create load summary reports. It allows you to see what's upstream or downstream of a given location. You can use it for valve isolation tracing for water utilities. If we have a pipe rupturing, which valves do we have to close in order to isolate the leakage? Okay. Now, let's see. Basically, what tracing is doing at a very fundamental level is assembling a collection of network elements that meet a specific criteria. And then we use the network data to provide, and it's using this network data, the attributes and whatnot, to provide value to utilities and answer these complex questions. What valves need to be closed to shut off a gas leak? Help you to design future things. How many houses are fed by a transformer? Can it accommodate additional load? Organizing your business practices, such as after a storm event, where should the field or work crews walk in order to see how the power lines are doing? What needs to be repaired? The basic types that we provide out of the box, there's a collection of 8 or so of them. You can see them here. And then these, of course, can be configured as this is a framework. Okay? You can configure these things through scripting or GP tools or through the user experience. Okay? Attribute propagation. This is an interesting advanced concept of the utility network, which allows you to calculate the values of network attributes downstream of the controllers inside a subnetwork. Okay, that means that when you make an edit to the feature data, you don't have to necessarily perform edits to all the downstream things in order to have a correct analysis result. So let's give you an example. That seems like a lot of doublespeak, but let's go and look at this little electric network where we have a controller, okay, and it has a source side and a load side, and let's say it's providing 3-phase power, ABC, everywhere. Now, in this example, we're going to show what happens if phase A is de-energized and what happens downstream of that, and when we're only going to make an edit to one feature to represent something being the phase A being de-energized. So let's say this is our edit. We go and say that, well, this device at that location no longer is running ABC phase, it's only B and C. Maybe it's like a switch bank, or maybe it's a fuse bank and one of the fuses popped, the A fuse popped, or maybe the A switch was opened, so it's only letting B and C through the device. So what happens, and we'll show the propagated value in green on the bottom. Propagated value initially at the controller starts off as ABC, and it's going to move downstream off the load side. Of course, the next device, the first device in sequence, is ABC. Then we get to this next one that has the local edit, so then the propagated value becomes BC. Now, when we have a propagated value of BC that's going to a downstream device that is only supporting AB, the propagated value will be B phase, and then B phase at the very end. So, by changing the device to say that the phases that are supported through it go from ABC just to BC, notice how we didn't have to modify the two devices on the easternmost side to say that, oh, we also removed A from each of those because they're downstream. No, we used propagated values to do that. Now, if you're going to be propagated, if you want to utilize this propagated capability, then the values have to correspond to network attributes, okay? If you had a pipe network, maybe the pressure of the pipe network is the network attribute. Let's have a little example with pipe networks where we look at the PSI of the devices. And we can see 100, 100, 100, and then on the far east side, 90s. Let's do an edit, and let's say this device, maybe it's a pressure regulator or something, and we switch it from allowing 100 PSI to maybe 80 PSI or something like that. Now, propagated value starts at 100 at the controller, start going downstream, see 100, 100, 100. We hit the 80, and at this point, the propagated value is no longer 100, but 80. We take the minimum of the two in this particular case. So then the propagated value moving further downstream is also 80 PSI, okay? So it's also, as you can see, it's very interesting. Both we've given you an electric example as well as a water example or gas example, just showing how you can use propagation and a single edit to something that corresponds to an attribute that is associated with a network attribute can be used to control propagation. Now, these propagation configurations are defined at the tier level, and of course all the subnetworks in that tier will have them applied to it. And you do that through set subnetwork definitions GP tool when you're constructing and configuring your utility network. There are various properties that you'll be configuring here. You know, the attribute being propagated, the function you're going to be using, whether it's a bitwise and, we saw that with phasing, a min or max. Min was used with the pressure example we just showed. There will be an operator, the value that is compared with the calculated propagated value, such as local PSI constraint or something like that. You have the propagated attribute, and you can also have substitution attributes. We'll talk about that a little bit later. So, propagated values, before we do the main trace operation, we'll go and calculate as a pre-processing step these propagated values, okay? Then they can be used during the trace operation, okay? For the functions, 3 functions are available. We talked about it a little bit before, min, max for numerics, and bitwise and for numeric values that are representing bit set values. So as an example here, we show you what you can do with electric data. If you're representing A, B, and C phase as 3 bits or a number between 0 and 7, with 7 corresponding to ABC, which would be bits binary 111. You can go through this at your leisure. You can stop the video and work through it. It's pretty straightforward if you understand bitwise operations. Substitution, this is an interesting one. A substitution is a type of network attribute, and it's used to calculate the propagated values for features with the attribute substitution category. And you can do actually pretty interesting things with attribute substitution. If you're going to use it, you must have propagation configured, and it's oftentimes used, say, in an electric network when you have lines being tapped off of other lines, or maybe a phase swap is occurring inside your electric network. Now, let's go through an example. Here's an electric example. Taps are allowing the propagated values they allow the propagated values on the main line to go right through the tap without paying attention to the propagated value off of the tap or of the tap. So in this example, you can see horizontally we have the controller and ABC phase going all the way across. In green, we have the tap, and on the tap, it's saying we're only going to pull off AC, phases A and C. And then downstream of that, you can see it moving to the south, and again, it moves towards the east in the middle, and there's a second tap, and the second tap is just going to take A phase off of the AC line, okay? So, let's say we do a substitution. We're going to say that tap that was connected to AC is now what was connected to phase A is now connected to phase B, and what was connected to phase C is now disconnected. It's not connected to anything. It's null, okay? This is the substitution we're going to do. So let's walk through propagation under this circumstance, this example. Again, propagated values ABC. You can see that walking across the horizontal. No surprise there. And again, the tap does not impact the propagation there on the main line. But when you go downstream of the tap, you can see phase A goes to B through the substitution, phase C is null. So what the line moving south used to be AC, now it's only B. Then the next device, no longer AC, it's now just B. B on the line going to the east. Now you hit a tap that's pulling off of phase A, okay? But A has moved to B, so we actually see B continuing to move across and B moving downstream. So, yes.
So, Eric, can I ask you a question right here?
Yeah.
So, you're demonstrating the phase drops or phase changes. Do you also have the ability using the attribute propagation to showcase the load as it's changing from the 3-phase to the 2-phase to the single phase?
That sounds like witchcraft to me, Remy, but I believe the answer is yes. That's a very advanced usage concept, but yeah, you can. God, what kind of terrible question was that? Okay, substitutions. How do we encode them internally? Well, this is pretty geeky, but it's kind of showing you we can show that initially when you start off with ABC phase, what A changes to. You can see in this example, that's the blue collection of boxes. B in the middle, you can set what it is changed to, and C what it is changed to. Okay, so in this example where AC goes to B null, in the blue, you see A, which is enabled, then goes to B in the blue. B is not used, so there's no substitution here. And C in the red or orange color is moving to, again, a null if you look at that bottom row. Now, how do we encode that numerically? If you looked at all the bits and did all your fun computer science multiplication and all the rest, that would be represented as a numeric value 128, okay? Where 2 to the 7th is essentially, that's what 2 to the 7th is, and that's where B is enabled in the blue. Constraints, we only allow you to do this on network attributes that have 8 bits, because then the substitution would be a 64-bit numeric, okay? And that's the limitation. Again, another example, 2 more examples where on one side A is going to B and C is going to null versus A going to null and C going to B. Okay, so you have a different substitution. And you can see in this diagram how it works out. It's a good one to stop the video and look at it a little bit carefully, but it all starts to make sense. Here's a phase swap example where we're saying that originally we have a tap that's tapping off of phase B. And upstream of that, we have a phase swap where B is going to A and A is going to B. We flip those two wires. So how does propagation work with the phase swap, with the substitution of that type? You can see ABC, 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 but B goes to A, so the tap off of B would become an A. And so you'll see A heading south, okay? Stop the video, look at it, it makes sense. So, wow, that was brutal. Dave,
thank you very much,
show us something interesting.
It will be interesting.
Yeah, my PowerPoint demo was terrific. Nothing crashed, but let's see if your demo crashes.
Thank you very much, Eric. So, as you noticed, based on the proportion of slides that we dedicated to everything there, analytics and tracing are obviously where a lot of value are brought into the utility network. And as this is the version of the advanced session that we're targeting towards the developers and the Developer Summit, as we go through this, I'm going to try to highlight the locations where there's extensibility and programmability and customization that you can do. I'll focus on within the Pro App itself, but I'll also call out where we could also modify these things and extend them elsewhere. Again, try to give developers a little bit more context as we go through these things. So, you'll notice first I'm looking at an overall network here. This is a Naperville sample data of electric network that I'm looking at. So at the top level here, I see my circuits. I can see some high-level circuits. Great. The first thing we want to call out is when you have a utility network in a map, you get access to our utility network ribbon. Nothing quite advanced yet. But within here, you get access then to all of our tools that will interact with the utility network itself. And the most impressive or interesting one, the one that we're going to focus this entire demo on, is tracing. So how do I get to tracing? There's actually a couple different ways in the Pro app that you can interact with our tracing framework. So you could start by using the Find Subnetworks pane itself. And within here, you get a view of all of the subnetworks that are within your network. I could right-click any of them and trace it. And that's sort of your first interaction with tracing itself. That's obviously a very basic way to execute a trace. It's a very quick way. You don't have to interact with a tool. So if you had a user who's doing a pull-off in a workflow and they need to go and add some new service and they need to confirm it hooked up to the circuit they expected to be serving it, coming to this pane, right-clicking and tracing will let them know that the area they've added is actually included within that subnetwork. The trace that's executed here is the subnetwork's definition trace. How can you see what that is? Well, in the properties of the utility network itself, we can go down into our domain networks here, in our case the electric, go and look at the tier definition, and in this very helpful dialog, you can actually go down and I can look at, for example, one of our electric distribution tiers. One thing you'll notice, it is very hard to read on a screen, but you can go along and it has all sorts of configuration in it. And at the very end here is actually the trace that is defined. That is the trace that defines what ends this subnetwork, where does it terminate, what devices are included within it. If we have those propagators, as Eric was describing, you'll display them here. So in our case, the network attribute we're propagating is our phases current. We use that bitwise operator because we want anything with where it's ABC. Here is a field that we actually, what we call burn in the value to. In our case, it's called phases energized. I'll show that on some of the data as we work our way around it. And then the last bit is in this square brackets is the network attribute that you can use to substitute the phases, do those phase swaps as you work through your data. So now what we're going to do is show you the other ways to get to our tracing tool. The most basic way is you open the analysis tab inside of our geoprocessing window here. You can scroll down to the utility network tools. They are an alphabetical list, so we are right near the bottom. You can open the trace tool itself. Now, this tool will take a moment to open. And when you open it through the toolbox itself, you'll notice that there is nothing pre-populated except we pick for you the connected trace. It's the basic trace. We don't give you the utility network input or anything else. However, there's an easier way to interact with some of these traces. If I just hide this window over here. And that is within the utility network's toolbar itself, we provide you a little gallery. And this gallery will contain the 8 default traces, connected subnetwork controllers, upstream, downstream loops, shortest path, and isolation. Isolation is relatively new in our software. And then you can notice that down here, I also have 2 custom traces written, or 2 tools that have the hammer toolbox telling me they are custom scripts. So this is obviously your first point of customization, something that you can easily do within the Pro experience itself. You can use Model Builder, and within your project's toolbox, create these models. Now, the models I have are pretty simple. They just chain together a couple trace tools and this Add Locations tool. Add Locations is the key tool whenever you're working within these models to chain traces together, because that is what's going to allow you to take the output from this trace, which is actually going to be a selection in my map, select those features and turn them into starting points or barriers, and then feed that into a next trace. And then the end result of that trace is what I actually want to display in my map. So you might ask, how did I manage to get that trace that I built into this gallery? Well, it's quite easy. You click, I did it a little bit quick, but this little drop-down arrow here, and down here there's a Customize button. Now within here, I can move traces around where I want them to show up on the ribbon. Perhaps I don't want any of my users to see an out-of-the-box subnetwork trace. I only want them to be using the pane itself. I can remove it directly from here. Click that little X and away it goes. I can drag mine up, set them up the way I like them, and now my user experience with just a couple little clicks and a model, simple model that I built, is customized so that my users have the best experience as they move forward. So now that we sort of explained that, let's do some actual tracing. So I'm going to zoom in here to my little trace location that I like to demo with. No special reason for it, except that, I don't know, I like it. And we go in here, and the first thing I'm going to do is just fire a connected trace. So for anyone who comes at this from a geometric network stance or a network model stance itself, we have two different concepts in the utility network. There is connectivity and there is traversability. Connectivity is the physical network graphs representation of what is connected to what. This uses the utility network rule base and our validate or build engine to stitch up that logical network together, and that will return to you the raw information of what is connected. Now, if I tried to run this trace, nothing would happen. And the reason for that is this trace locations button is actually quite important, because this is where you define your starting points and your barriers for your trace. So now if I was to go in here and click, for example, right here, I can start on the switch bank, which is not where I meant to start. I meant to do this. It won't pick it. But we can go to this switch bank, for example, and try to run a connected trace. And what we're going to do throughout the rest of this demo as I click my way around it, so you'll notice only one thing was picked. The reason for that is that I'm actually picking a container here, or an assembly, that contains other things. That assembly does itself not actually participate in the connectivity graph, which is why that connected trace doesn't return anything. However, if I actually get in here and I pick, for example, this line, which does participate in the connectivity graph, and I run that same connected trace, it should now go out and pick for me all of the features in my little area there. So I'm going to get 27,000 features selected. It's obviously not the most useful trace in the world, but we're starting to get there. So now in this demo, as I said, we're going to just walk through all of these advanced options. There is a ton of options on this tool. These can obviously all be selected and set up within a model builder, a model, so that your user only has to click the tool up here in the gallery versus having to navigate their way through it. But anyone watching this is going to have a hard time customizing it if they don't know what they all do. So how do they actually work? So the first thing we work at is, as I described, there is a difference between connectivity and traversability. So right now, this connected trace just returns whatever is connected. But if I wanted to restrict what it could actually trace through or what the trace results would look like, that is what this traversability section does. This will block traces that violate, or block features from being traced, which violate any condition or function that I put in here. So for example, if I was to say only trace where devices, or where, sorry, I'm speaking to it backwards. The condition is the condition that allows the traversal. So I'm going to say, as long as there is no devices that are open, I'm fine. I'm allowed to traverse. So then I can go and click run, and it should go through. I should get a few fewer features because it should get blocked at some point. So you see I get 9,000 features. I start to trim those results. I start to get traces that mean more. So that's interesting with a connected trace, but some of these things are much more interesting if we actually look at directed tracing. And so what are our directed traces? Well, we have upstream, downstream. In the old geometric network, these were driven based on the flow direction, and flow direction could have been generated using either sources and sinks or digitized direction. In the utility network, all of our directionality in the network is actually derived on the fly by the analytic. And the way it does it is it traverses up to the subnetwork controller. It then finds, based on that controller's terminal configuration, what the direction of flow is, and then it circles back and traverses the network using that directionality. So from this same location, if I run a downstream trace with that same condition, because it hopefully doesn't block anything, I should be able to run, and it will now go only to, I hope, the left, because that is what is downstream. My controller is up and to the north of where I put that starting point. Now, one thing you may have noticed is as I picked this tier, we actually saw some information start to get populated down here automatically. And what that is that was that configuration that I showed at the beginning in the properties page. Once you pick a tier, we automatically digest the subnetwork definition or the tier definitions trace configuration. We pre-populate the tool with that information, essentially trying to help you so that the downstream traces, the directional traces you're working with make sense based on the direction of flow in your network or how the subnetworks are defined in your network. But within that, you could always go in and start cleaning some of these out. You could remove them. It will not remove it from the subnetwork's definition. It will only remove it from the trace that you are running. Key distinction. So now one last thing here. So we have these function barriers. So how do these work? So as I said in the traversal section, is this determines whether or not we can even work our way along the graph. It's not a raw just are these things connected? It's are they connected and can I actually traverse through these things? So for example, if I wanted to add up shape lengths and say don't go anywhere or stop when the shape length is greater than say 500, and I was to, doesn't want to let me do that, and I was to run that, what it should do now is it should actually fail. And the reason it fails is because it tries to go until it finds a value that is greater than 500. However, in order to get to the subnetwork controller, it has to traverse along shape lengths that are greater than 500, which is why it fails. And hopefully it tells me that the subnetwork controller wasn't found. Again, that's highlighting the difference between connectivity and traversability. From a connectivity standpoint, I can get up to that controller without any issue. But from a traversability standpoint, once I put that filter on it and say you can't go any longer than 500 meters, well, now it can't go any longer than 500 meters. Can't get to the controller, means it stops and you get that failure. You can also choose to apply these traversability filters to either junctions, edges, or both junctions and edges. So we're going to close that guy up and move into filters. So now filters are the same general idea. There are barriers and functions that you can set up to restrict your trace, but these are applied after the fact. So these do not affect the actual traversability. So what does that actually look like? Well, let's say, for example, I was going to say that same function I put into the traversability, I wanted to add up all of my shape lengths. And if the value of that addition is greater than 500 meters, then I want it to stop. Well, again, as I described, I'm doing a directed trace, which means my traversal must get to the controller so that it can derive directionality and figure out where downstream actually is. And what you'll notice this time is that once I define that and I set my values and I run it, the trace will actually succeed, but it will not provide, and I should have zoomed out when I did the original downstream trace to show you, but it would actually restrict the amount of features that are being returned based on this filter. So you'll notice this whole section here of secondary did not get selected. And that's because if we zoom out here and look, we can see that this line is the only thing that got selected. Once we trace that line, we've discovered that we are greater than 500 meters, and we stop the traversal. Now we have this little checkbox, use local values. And some people might say, well, what does that mean? You'll notice it was unchecked there when I ran it. So what that means is it uses a single global value to determine when this function gets hit or stops. Now, if I say use local values, what it will actually do is it treats every pathway from my starting point as a unique path, a unique value. So what it should do is now that I'm using local values, you should actually see a couple more edges get picked up here. As you can see, it got into the secondary. And that's because the pathway that gets into this secondary down here is actually less than 500. It ends up in here. And this pathway is treated as a separate one, and this pathway is treated as a separate one. And so instead of hitting one global value that stops the trace entirely, you can actually fan out and find each pathway. So stop when each individual pathway is greater than that value. We're just going to remove that one. The next thing to show are these functions. And what this is this is allowing your traces themselves to do some math for you, to do some addition, some maximum. If you want to know maybe the total length of conductor that's in your subnetwork, or maybe downstream from a specific location, you have to swap out a device, you have to do something, you have to switch a bunch of conductor for some regulatory reason, you might want to know how much there is there. So from that point, I can say add, and just add my shape length. I can choose to further filter it, so I could say add shape length where the phases, for example, are only B phase, or where it's A phase, or where it's any phase. In this case, I just want to know the raw value of what my shape lengths are. So I can run that trace, You'll notice now it obviously picked a lot more features on that downstream trace because I've removed all of those traversability and filter functions and filter barriers. And if I scroll to the bottom here, you can see that I have 33,635 units worth of shape length of my conductor to the south of me, which is interesting. And you can obviously understand the power here. We have things like average, count, minimum, maximum. You could say, what is the longest piece of conductor I have in this area? What is the biggest of some other value? Maybe the highest pressure that I have in a gas network, something of interest like that. Next thing to show here are our outputs. So what these outputs allow you to do is filter what it is you're getting back. So let's say I'm at a location where I know in that conductor I picked, there's a cut in the conductor. So I need to determine who all my customers are downstream. Well, I don't need all of these lines to get returned to me and try to then do further refinements of my selection within Pro itself. I can let the trace framework do it for me. So I can actually come in here and say, in my electric devices, I'm going to look for a low voltage service line. I'm back in assemblies. So you go there, low voltage, and I could go find my service meter, wherever they are, there they are. And maybe I just wanted to look for my single phase residentials. Now, this is an additive list. So as you add one, it should give me the option now to add additional ones. So you're not restricted to a single output asset type. You can add as many as you want, as many that are of value to you. I could run that trace. I'm running the same trace every time. You'll notice we're just restricting the amount of information coming back, trying to target in on information that is of use. You can see now that I only got 40 things. So I know downstream there's 40 customers who would be impacted at a single phase residential for me potentially taking this circuit out. If you had a special asset type, asset group for high risk customers, hospitals, things like that, schools that can't come down or need to have special considerations, this is obviously where you could configure that as well. And then the last one is you can also output based on conditions. So I could say, output me things where my device status, and that you can pick any network attribute within here. We expose them all. So I could say pick anything where my device status is equal to open. Maybe I'm running a trace and I keep stopping the trace at some point. I don't seem to understand why it keeps stopping at a location or why it's not going past some point. I could run this to find all my open devices, or perhaps I want to find out where my tie switches are. Well, these are going to be switches between two circuits that are going to be open. So I could say asset group, asset type of only the switches, find me the open ones, and in this case I find one feature, and if I go look at it, it is in fact a tie switch. In the interest of time, I will zip through that and not. Now what I have here are these two customized tracing, and so what we've actually done with the utility network, as Eric had mentioned, is that it uses branch versioning. And what is branch versioning really? But it enables temporalness to the network by default. So for example, I can go into and I did it a little bit quick, but from my layers tab, I can click on my data sources. I can right click my version or my default moment, and I can change it. And I can actually change to any time that I want. So for example, in my network, I know that last year, right around the UC, someone put an outage into my network. It happened at about 6:10 p.m. And hopefully that takes. And then I can click apply. And it takes that moment defined, it applies it to the version management server, and now it presents to me my data as it looked at that point in time. I can then, because I've got those two traces together, what I've actually configured is the first trace will run a downstream trace and find me the device that was blown out. The second trace will use that device as the input to the next trace, which will then tell me the customers who were actually out as a result of it. Now, I configured this trace so my user doesn't have to input anything. They can just click run. All of this configuration could also be done through our managed SDK. All of our tracing framework and options are exposed through there. There's nothing available in the UI that is not available in our managed Pro SDK. You can also script this through Python or through any of our web applications hitting the REST directly. So you can see now I've completed, and I've got my 565 customers who were out as a result of that outage. If I zoom in a little bit, we should see some of them start to show up. as their images come in. And those are all the customers I need to go notify that 2019 outage affected them. The reason that there is two different ones is that I'm operating on two different circuits, but you could very easily in Model Builder, so if I was to open this one, for example, I actually have this trace hard-coded to run against RMT005. You can see it's sort of in the middle there. But I could always right-click this thing and say create variable from parameter, and I could say my subnetwork name is actually an input that the user is going to define. I could set it as a parameter. Ooh, my mouse doesn't want to cooperate now. Set it as a parameter, and then save this thing. And the next time I open it, whether off the ribbon or directly out of the catalog pane, it will then prompt me to provide the subnetwork name. Now, you can obviously, anyone who's done Python configuration knows that right now this thing is going to show up as probably just a drop-down list of all of my subnetworks in the system. I could pick any of them, and it will turn around and run that same trace. Find any open devices, use that as a starting point, find me all the customers who would be out as a result of that customer, or that outage. So obviously that's showing a couple different things, customizing these traces using Model Builder, exposing different parameters to make it a little bit easier for your users to integrate through, going back in time to do historical traces, as well as an understanding of all of the different options and configurations available out of the box with our utility network tracing framework. Now I'm going to throw it back to Eric, and we'll see you in a bit.
Okay, now that was a very interesting yet disturbing collection of demos, Dave. Interesting, yeah, I think you highlighted the trace framework really well. People, I think, it is pretty clear why we call it a trace framework. You also brought up the temporal aspects of branch versioning. That's also very cool, and that's one of the things that we really like about branch versioning as a real value add type thing. I think people will be able to do a lot with it. Now, the disturbing aspect to the demo was, why does it take the power company a year to let me know that I had a power failure? Remy, is that how it really works?
Well, not really, Eric. What you're seeing is a moment in time. Obviously, they restored the power, and we went back and saw the event prior to the restoration.
Yeah, okay. So that's okay. I'm better with that then. Thank you for that clarification. What are subnetworks? Okay, it's basically, think of a subnetwork. It's a geeky term for a subportion of your network that you use for particular purposes. Like you can drive analytic operations. You can use it for labeling. You can assign units of work. You can export these subsets of your network to external systems. So in any event, think of a subnetwork as it's basically a subportion of your network. If you were in the electric domain, it might correspond to a circuit or a feeder. If you were in the pipeline domain, either gas or water, think about it being a pressure zone or an isolation zone. With wastewater, think about it being trunk lines. These could all be subnetworks in these various different domains. And it's basically, think of them domain networks as a way to organize your subnetworks as a way to organize your domain networks inside the system. It allows you to model these large, logically separated pieces of the entire system, such as here we see things such as transmission, distribution, and structure. Now tiers are actually interesting. Inside a domain network, you can actually start to demarcate logical levels within it. So with electric distribution, you might have different tiers. One tier corresponding to subtransmission, one to medium voltage, one to low voltage, okay? Subnetworks only have one tier. You don't have to have more than one tier. Use as many as you want. And domain networks, of course, can have one or more. Structure networks do not have any tiers, nor do they have any subnetworks. Let's see, the interesting thing here in the essence of time, one thing, subnetworks always have one or more subnetwork controllers. Think of the subnetwork controller as the place that's the origin of the resource that's flowing through the subnetwork, okay? Or if it's a sync-based thing, it's the destination of resources within the network. And let's see, the subnetwork names and subnetwork controller names are maintained by the system as a managed attribute on the device feature classes at present. Okay, Dave, do you want to give another quick demo?
Absolutely. So we're going to try to do justice here to network diagrams as quickly as we can while still giving them good their due. So as we saw previously, I was using the Find Subnetworks pane to look around my network and see the different subnetworks and do some tracing. Analogous to that, the diagram section of our utility network ribbon contains this button called Find Diagrams. And so the key thing here is there's 3 unique types of network diagrams in our system. There are system diagrams. These are the diagrams where you define a template that is going to create your diagram. You assign that to a subnetwork's definition. And then whenever that subnetwork is updated, so too is its associated system diagram. If ever it gets out of sync, you get this nice little warning that tells you it's not consistent. You could then write, or you can click it, and then you can update it down here in order to make it correct. However, we're going to look at one that is correct. So you can open these diagrams simply by launching them directly off this pane. And again, this green exclamation point is actually what tells you it's a system-maintained diagram. See, system diagram, the little helpful pop-up. And what you would notice is, for example, I opened RMT001's subnetwork diagram, and it is a very simplistic diagram. It only really shows the switches. And that is because primarily when you're looking at these overall circuits, there's only key devices or pieces that are of interest to the people who would be looking at it from this perspective, the electrical engineers, the GIS analysts even. You don't necessarily need to know where every single little device on your network is, every tap, every connection point, but it is of interest to you where all your switches are and where your fuses perhaps are, or the devices that are really of importance, perhaps where the circuit breaker itself is, where its container is, things like that. The other kind of diagram is what we call a temporary diagram. And you can generate a temporary diagram by simply zooming into a location of some interest. I'll go here. I can select a couple features, and I will truly select just a couple features. And I can say New Diagram. When you click New, you get this little drop down of all these different kinds of templates that you can apply. These are all the templates that you've created, configured within your network. Again, this is a point of extensibility. You can create your own new diagram templates, you can assign them into the diagram, and then they will show up in this little drop-down list. So in my case, I could pick a basic diagram template, and then it's going to generate it. The key being that when this generates, and it opens up and it shows me whatever I have selected, this is a temporary diagram. If I close ArcGIS Pro and reopen it, it's gone. It didn't get stored anywhere, and it only lives for the lifespan of my session. Now, if I wanted it to live longer than that, I can store it. When you click the Store Diagram option, you get to give it a name, you get to give it access permissions. The access permissions are the same as like versioning, so public, anyone can see and edit, protected, anyone can see, not edit, private, no one else can even see it except for you. You can give it a name, and then you can give it some tags for the purposes of lookup later. For the interest of time, I'm not going to do anything with this diagram or store it, but what I will do is open what I have as a stored diagram. And so these diagrams that are stored, you notice they do not have the green exclamation point, but they do live in my network itself. Every time I open Pro, I open this pane, I get access to them. This diagram happens to be off of a circuit breaker. It's just a very simple switching diagram that we generated. So you might ask, well, how do we generate that? You had to select a lot of things. Did I have to run analytics? Did I have to run tracing? What did I have to do to actually generate that diagram? Well, the diagram team recently installed in what they call a trace rule into their diagram templates. So for example, I can click this circuit breaker. I can define a trace within my template itself. In this case, we have a circuit breaker switching trace. And all that is it runs a downstream trace from that circuit breaker, and then it cleans up some of the nodes and the information that the diagram will display, so it gives valuable information to the user. So as you can see, I have one feature selected, single circuit breaker. I've clicked Generate Diagram using that circuit breaker switching diagram. And what is going to generate for me is a temporary diagram that has run a downstream trace off that circuit breaker, pulled in that subnetwork, node reduced it out to only show the information of interest, and then generated that diagram. And as you would notice, this diagram and this diagram look the same. And that is because it's the same circuit breaker I used to generate them. The last little thing I like to call out here is that, and this is supported on the temporary, on the stored, and on the system diagrams, is that you can do white space editing in here. It uses all the core editing tools of ArcGIS Pro. There's no special customized editing tools in here. So I can click anything, I can go to the Edit tab, and I can actually move things around. As I move them around, you'll notice you get rubber banding behavior, the way the geometric network used to give, and the way that the utility network editing will work within Pro itself. If you don't like that, or you want to move things around without the rubber banding, this disconnect button becomes your best friend, because you can click on that. You can then move things where you want them to go. And maybe I actually do want that line to come along for the ride. It was annoying me that it kept moving as I was moving. So I can click that. I can unclick this, and you can actually see that it's going to show me where that line is going to move to. You get a hint, go, oh, I don't like where that's going to, put it back. You could save any of these edits when you're done, save the diagram, and it will remain saved by the time you reopen it, so long as it's a stored diagram. Remember that any edits you do to the temporary diagram will go away the second you close Pro, the session. So in that demo, it's sort of a very high level and quick overview of some of the network diagram capabilities. We also have the ability within these diagrams to make selections and start passing them back and forth between the diagrams, between the maps. In the interest of time, I'm not going to do it, but of course you can do that. And all of these things are customizable up on this ribbon. You can remove options, you can add options depending on what you want your users to do. You could use this add-in toolbar to write your own custom things that work with diagrams. You could add your own fancy tools and add them directly to this ribbon using the DAML extensibility within ArcGIS Pro itself. And all of the functions I showed are also available again through our managed SDK, and some of them are even available through Python. Most are, any that are exposed through our GP tools. Thank you very much. Back to you, Eric.
Okay, so Remy, another good demo. I'm glad you brought up network diagrams and all that. Unfortunately, we didn't have slides talking to it for time's sake, but I think you showed a lot of cool capabilities. Remy, what's going on with the utility network?
So it's been really interesting this past year. Matter of fact, the current release, we spent a lot of time on performance and optimization of the network topology, and especially the dirty area management. I think that as users begin to use the 10.8 and 2.5 release, they'll see some really good optimization with that. Additionally, we just released file geodatabase support. So now you can do your prototyping on a file geodatabase. The challenge with that is it is single user only. You're unable to publish it to the web or publish it or sync it out to the runtime. You can only use it, single user. Couple of other things, a licensing modification. Hussein and I covered that in the intro to utility network. So if you're interested in more details about that, I encourage you to look at that video. And we were excited to see tracing and runtime to be exposed. Looking forward to the next release, the non-spatial feature support to support network underground and telco, as Eric mentioned, is a big part of that release. We think it'll be really exciting to see our partners and distributors start to build models with the non-spatial elements exposed. We also have split with relationship classes. That was something that was asked by a customer so that you can modify the behavior on a split and determine what will happen with related features. To show partial edges in a trace was also another big thing that's been asked. Up to the summer release, when you execute a trace, as Dave was doing, the whole feature element was selected, but the trace distance was returned in the message. We hope to see the graphics actually more represent the trace distance. A couple of other things, arcade enhancements, traversal of associations will be really cool. Once again, we're going to be working with quality and performance probably at least for another 3 to 4 releases, if not more. Updating propagated values in a named version. was something that our customers requested. Now, I will caveat that to say that there may be some performance issues in the initial release, but we'll continue working on that. We're still facing challenges with some of the discrepancies when you're working in a name version versus with default. Multiple structure attachments for a single device was another customer request. So now, for an example, on a transmission H-frame pole, you can attach the cross-arm to 2 separate poles. We're continuing to work on branch versioning improvements, especially with the user experience on, managing the conflicts and edits in the version window. We're excited to see the new trace network getting released this summer as well. That'll be a network designed for environmental hydrologic systems. That'll be, expand our capability into that world. And looking forward into the future, we will continue to work on non-spatial object support. We'll continue to work on quality and performance, runtime SDK. We've got some great things coming down the road with that. JavaScript SDK. We are working toward life in a disconnected environment, creating and storing trace configurations, and exporting and managing subnetwork enhancements through the JSON. So, got a lot of work ahead of us. We're really excited about it. We hope you enjoyed the advanced utility network session. And please feel free to reach out and let us know what you think. And we look forward to seeing you at the user conference.